Welcome to Techie Wise. So in today's video, we will be having a discussion on Hill cipher. Key matrix is used for encryption. So the key matrix is a square matrix. If I want to encrypt n characters of plain text at a particular point of time, then I will be going for key matrix of size n by n. So encryption is going to be represented as P cross K mod 26, and plain text, that is decryption, is done in such a way that ciphertext cross K inverse key matrix, that is inverse of the key matrix, mod 26. So this is the encryption process. So here we are considering three characters, encrypting three plain text characters at a particular point of time. So we are going for a 3 by 3 key matrix. So three ciphertext characters are generated. So how it is generated? P1, P2, P3 plain text characters cross in 3 by 3 key matrix mod 26. So C1 is equal to P1 multiplied by K11 plus P2 multiplied by K21 plus P3 multiplied by K31 mod 26. So this row, this column, usual multiplication. So we'll be getting the ciphertext. Now we can directly go with an example. So here we are going to consider 3 by 3 key matrix. So three characters at a particular point of time are going to be encrypted. So here in this example, we are going to take a 3 by 3 key matrix. So the values in the matrix will be less than 26. 21. So any values can be taken. In this case, we are taking this matrix. That's it. This is the key matrix. And the plain text, what we are going to consider for encryption is pay more money. So as discussed earlier, I'm going to take three characters at a particular point of time, and we are going to proceed with the encryption part. So if the pre-processing is required, I have to group these this plain text as three characters each. So PAY is first block, MOR is next block, EMO is another block, and NEY. If suppose the last block is not full, then in that case I can go for the fillers. Less frequently used characters are used as fillers. Okay, so now we are going to encrypt, take three characters at a point of time, and then we are going to proceed with the encryption. And here we can take the positional values of each and every character. So P is 15, positional value of A is 0, and this is 24. And similarly here, this is 12, just alphabetical positions, that's it. And this is 17, like that it goes on for the rest of the characters as well. Then I'm going to take PAY as my first block to proceed with the encryption part. Now I want, if I'm encrypting, I'll be getting three ciphertext characters, which I call it as C1, C2, C3. So which is going to be the positional values of my plain text, that is 15, 0, 24. And then my key matrix multiplied by my key matrix, that is 17, 17, 5, 21, 18, 21, 2, 2, 19, mod 20. Mod 26. So this is equivalent to 15 cross 17 plus, that is this row and this column, plus 0 cross 21 plus 24 cross 2, then 15 cross 17 plus 0 cross 18 plus 24 cross 2. 24 cross 2. And next is 15 cross 5 plus 0 cross 21 plus 24 multiplied by 19 mod 26. So this is equivalent to 303. If I product and add these things, I will be getting 303, and this one is again 303, and then 531 mod 26. So 303 mod 26, yeah, it is 17, 17, 11. So which is equivalent to R, R, L. So PAY is taken and then it is encrypted to its equivalent R, R, L. So this is the ciphertext. With regard to the decryption part, you can check out with the rest of the thing. So if you are encrypting MAR, you will get the equivalent as MWB, right? You can try it out later. With regard to the decryption part, yeah, I will be going for the key matrix inverse. Here, how to find the key matrix? K inverse is equal to 1 by determinant of K multiplied by adjoint K. So here, once you find the K inverse, you can easily proceed with this task. So in order to retrieve the plain text, it is going to be ciphertext multiplied by K inverse mod 26. So now we can have the discussion on one more classical cryptographic technique, that is Vigenere Cipher. So here this is the simplest polyalphabetic substitution cipher, Vigenere Cipher, Vigenere, Vigenere Cipher, which is the simplest polyalphabetic substitution cipher. So here again keyword is used, similar to playfair cipher, keyword is used. So key need to be as long as the size of the message. And usually the key is going to be the repeated word, repeating keywords. So we are going to use the keywords in a repetitive fashion. Okay. So let us start with an example. So let us take the keyword as deceptive. Deceptive is the key, and the plain text. What I am going to consider is we are discovered. We are discovered is the plain text. Alright. So usual convention is we will not separate the words. When we are dealing with the encryption part, we will remove all the blank spaces. We will be removing the capital letters. All those things are the general constraints. So here this is the plain text. And then comes the key. So the key is going to be placed in the repetitive fashion. So here key is going to be placed in a repetitive fashion. DECEPTIVE. Now again I am going to repeat it. DECEPT. So here I am going to repeat it till the plain text gets over. Right. So here I am done with the task. So I am going to stop with this. Now we are going to proceed with the encryption. So how to proceed with the encryption? So here the ciphertext is going to be PI, position of the character, plain text, and then comes the key mod 26. So here in this case, the positional value of W, alphabetic positional value of W is 22, and the alphabetic position of the key character is 3. A, B, C, D, 0, 1, 2, 3. 3. So now what we are going to do? So 3 plus 22 mod 26. So which is 25, which is nothing but Z. So here in this case, W is going to be encrypted as Z. And similarly with regard to the decryption, so how the receiver will proceed with the decryption? the receiver will also know this key and he will have the plain text, ciphertext. He will be placing the key corresponding to the characters of the ciphertext, and then he will proceed with the decryption part. So in order to proceed with the decryption, it is nothing but P is equal to positional value of the character of the ciphertext. Sorry. Minus positional value of the character of the key mod 26. So here in this case Z. So here the positional value of Z is 25 minus the positional value of character of key is 3 mod 26, which is 22. So the equivalent is W. So this is how the encryption and decryption happen. Thank you.